The first thing we need to cover is some basics of exponents, okay? So 2 to the 5th, for example, is 2 times 2 times 2 times 2 times 2, right? Which is 32. So 2 to the 5th equals 32. We're going to come back to this in a second. 2 to the negative 4th. What does that negative do? Yeah, so it's 1/2 times 1/2 times 1/2 times 1/2, right? 4 times. Or 1 over 2 times 2 times 2 times 2, because the negative 4 flips upside down, which would be 1 over 16. So 2 to the negative 4th equals 1/16. The next one we need to refresh your brains on. What if I have 64 to the 1/2 power? So it is the same as the square root of 64, which is 8. So 64 to the 1/2 power equals 8. What's 64 to the 1/3 power? So that's the cube root of 64, which is 4. So 64 to the 1/3 power equals 4. Now, here's the new stuff. So this all has a base, an answer, and a power, right? All of these go base, power, answer. This is a base. This is the power. This is the answer. This is a base, a power, and answer. You're good with this? So this is exponential form. Okay? So when we go backwards, we call it logarithms. So the logarithm is log, base, answer, power. Log back. So this one that was 2 to the 5th equals 32 is going to be log of 2, 32 equals 5. Log 2 of 1/16 equals negative 4. So if you have a base that's a whole number and then you get a fraction, most likely that power had to be a negative. Now, the base on this one is 64. The answer is 8. So if the base is bigger than the answer, most likely it came from a square root or a fractional exponent. Okay? So log 64, 8 equals 1/2. And the last one, same thing, log 64 of 1/3 equals, oops, hold on. Log 64 of 4 equals 1/3. So that's the basic idea of logarithms. Okay? So grab your calculator. And first, what is this really asking if you put up, so this is logarithm. If I change it back to exponential form, what does this 5 represent? So that's the base. This 125 is the answer. And this needs to be the what? So 5 to what power is 125? 3. So that should be a 3 right there. Okay. On this next one, this is the base, this is the answer. So 7 to what power equals 49? So this is the base, this is the answer. So 49 to what power equals 7? 1/2 because it's the square root, right? Now, this one's kind of an interesting one. It says log, there's not a base, and it says 1,000. If you ever just see a plain old log, what does it mean? It means it is a base 10. Okay? So that is 3. 10 to the third power is 1,000. So if you ever see just a plain old log, it means it's an understood base 10. Uh-huh. So on your calculator, if you look, there's the log button without a base, right? And if I were to take my calculator and type log 1,000, it gives me that it's 3. Now on the other ones, if you hit math, and the short way is to go up instead of down, A has log base. Okay? So I could take 49 and put 7 here, and it should kick out. What did we decide that was? 1/2, right? Because the square root of 49 is 1/2. So, did you all follow on where to get that on the calculator? Math, move it up. There it is. Type it in, and you're good. Okay, there's one more thing that we need to cover as far as a basic idea. Come on. So here's the basic idea that we need to cover. Maybe. I wanted a blue background, but apparently it doesn't want a blue background.
I'm listening.
Okay.
I know exactly what you're doing right now.
E is a number. So if I go to my calculator, you know how pi is 3.14? If I hit second ln and I go e to the 1 power, 2.718. So e equals 2.718. Kind of like pi equals 3.14, right? Everybody just accepts that pi is 3.14? Well, accept the idea that e, unless you're talking in physics, then it's a different e, but this e is 2.718. Or is it in chemistry that you have that other e? So you have this e and it's 2.718. It's called the natural number. This is a natural occurring proportion. So instead of saying log e, so the logarithm of the natural number, right? That's what this says. Logarithm of the natural number. Well, they decided that that was kind of cumbersome. When I say they, I mean these math people back in some time period. They decided that that was a lot of work to say logarithm of the natural number. So instead, they said, let's just call it ln. So ln means we have log base e. So logarithm of the natural number. That's why it's ln. Okay? So ln means we have an understood base e. Are you ready for a trick question? ln of e to the 5th. What is the understood base on this? First, so the understood base is right here, right? This is the what? And this is the power, correct? So what this is really saying is e to what power is going to equal e to the 5th? What does that question mark have to be if this is equal? 5. This is really saying e to what power is e to the 5th? Well, if e to some power is equal to e to the 5th, that power has to be 5. Or else they can't be equal. So here's you another way to think about this. Anytime you see an ln and e next to each other, this is a huge idea. Anytime you see an ln and e next to each other, it's like they kill each other off and you're left with just that number. Okay. So if I had ln of e to the 27th, it's just 27. Or ln of e to the 3.52. 3.52. Because this is really just saying e to what power equals e to the 3.52? Well, if they're equal to each other, that has to be 3.52. Okay? Or you can just think of those killing each other off. All right, section 2. We need to understand a little bit about your exponents. Huh. AX times AB. X plus B, right? What do you do with powers when you multiply? Like x to the third times x to the fourth? You add, that makes x to the seventh. So we're talking about exponents, right? What happens when I have x to the 10th over x to the third? I get x to the 10 minus 3, which is 7. You all agree with this so far? So if you have this example, a to the x to the y power, that is just a x times y. So in order to get a multiply, you had to have a power to a power. If I have x to the fourth times x to the fifth times x to the third, what do you do with all of those? You add them, so that would make x to the 12th, right? Versus if I have x to the fifth to the 7th power. Power to a power, you times them. Okay. This is the idea we're going to use. Remember logarithms, base, answer. What's this part right here? This is the power or the exponent, correct? So when we're talking about logarithms, we're talking about powers or exponents. So the same rule that applies to these powers. So like if you have this, a base times a base, what do you do with the powers? We had two bases that are the same, you add the powers. Two bases that are the same, when you're dividing, you subtract the powers. So here's how that works. Get rid of that red screen. So here's how this works with logarithms. If I have log 7 of x times y, the multiply, we can expand this. So this is called the condensed version. So back to the previous page, when we had x, the base times a base, what did we do with these when we plussed? Okay, so a multiply. Here's another way to think of it. Every variable gets its own little log to sit on. Okay, so every variable gets its own log. So we can, this is condensed. Expanded is going to look like this. The multiply became a plus. Or if you want to think of it going the other way, the plus became a multiply. Okay, that's the rules of exponents. We're talking about having the same basis, so you add the powers together. That's how this works. But most people just remember that when we expand, each variable gets its own log. Okay, so if I have this, log 7 of m divided by n, how many variables are there? Two. So each variable gets its own log. And a divide becomes a minus. And now the only other thing that we have left, say we have x to the w power. Okay, this w goes in front. So w times log 7 of x. So if we have a power, that power goes in front. But it doesn't get its own log, correct. So if it's a power, if we have this to a power, that number goes in front. So this problem's as hard as you're going to see ever. Like, this is just, yeah. There's really no purpose on this problem other than to see if you understand the rules. Okay, it's not something that's going to show up in life. It's not going to show up in a story problem. This is just to see if you understand these three rules. That's all that this problem exists for. Okay, so realize That's the only reason it's there. How many variables are there? One. We have an x, a y, a z, a w, and an a. So there's 5. Each variable gets its own log. So I need to have 5 log 3s. Why 5? Yeah, because there's 5 variables. Each variable gets its own log. As long as you remember that, you'll be all right. Okay? So each variable has its own log. What's my first variable? So I'm going to put an x with this one. What's my second variable? So I'm going to put a y here. What's my next variable? So I put a z here. What's my next variable? And my next variable? Okay, so I've taken care of all my variables. Now, see on this one that had log 7x to the w, where did that w on this power end up? In front. So anything that has a power on it ends up in front. So the power on x is what? So that 3 is going to end up in front because it has a power of 3. What's the power on the y? So it goes in front. What's the power on z? So it goes in front of that. W is a 2, a is a 5. So that's the power on each of those variables. What's happening between x, y, and z? Multiplication, which means we're going to put it as an add. And I'm going to leave a little bit of space right here. Okay? And between w and a is also a multiply, right? So all these ones that are multiplied together have a plus between them. This one doesn't have anything between it yet. Why? Because it's a divide. And I'm going to put this in parentheses. And I'm going to put this in parentheses. I'm going to leave room for my other parentheses. Okay? There's going to need to be some room in there. So it's all of this stuff divided by this stuff. So that's why I put it in parentheses. Okay? Now, what's the only thing that I have not taken care of? I've taken care of the times. I've taken care of these powers. Okay, the square roots. Those were what? When we rewrote them. Like, I had 64 to the what power made 8? 1/2, right? The square root of 64 is the same as 64 to the 1/2 power. So the 1/5 is a power. So it's going to go in front right here. So I'm going to put 1/5, but it's only on these first 2. So why is that 5th only on those 2? Because x and y are the only 2 under the, under that root. Where's my other root? So this w is going to have a 1/3. Now I have everything written out that could be on there. So this is the condensed version. This is the expanded version. All right, so there's an expanded problem. I want you to condense it. So it says 1/3 2 log 4 of x plus 3 log 4 of y, parentheses, minus 3 log 4 of w minus 1/3 log 4 of a. So when it's expanded, every variable has its own log. When it's condensed, they all just take those log pieces and put them back together to make a tree. No, I don't know. There's still just one log. No, there's only one log now, okay? So when we what color's going to show up? So when we condense, there's only going to be one log. So log base 4. Okay? My first variable that I run into is x. What's its power? 2, because that's the number in front of the log with the x, right? What's the next variable I run into that's still inside this parentheses? A y, and what's its power? 3, because that's the number in front of the log. Now all of this is in parentheses, which means that all of this is together, right? And it's under this 1/3 thing. What does this 1/3 thing mean? So the cube root. So that takes care of all this stuff until we hit this minus sign, which means what? Divide. See how both of these are minus? That means they're both on the bottom. So like right here on the problem before, if I'd have taken this minus sign and distributed it, it would have been minus 2/3, because 1/3 times 2, log 3w minus 5/3 log 3a. So you could actually distribute the negative in. Okay? So that's all that this negative down here has happened, is it's been distributed. So I'm going to put in a divide. My variable that I run into is w, and what's the power on it? And my next variable is a, and the power on that is 1/3. So I can either put the power like this to 1/3, or I could have written the cube root of a. Yeah. So I'll accept either of those two right there.
Where's the minus going from the 1/3?
So this minus is just what's keeping it on the bottom. If it would have been a plus,
So that minus wouldn't have to be there.
correct. Yeah, so if I would have written it like this, I could have written it like this, and it would have meant the same thing. So that's the same idea with that. All right, section 3. Now you're going to solve. Should we start off crazy? Yeah, why not? So I'm not going to go too crazy, but we're going to do a little. I should have started easier. Oh well, too late now. No, let's not do a log on that end. So let's work through this. This will build up a whole bunch of stuff that we're going to use. One thing when we're going to solve problems with logarithms or exponents, we don't want multiple logarithms. We want just a single logarithm. So we need to take this expanded version and condense. So what is this stuff on the left condensed to be?
5x.
And then 5x, right? Because we multiply those, the plus turns into a multiply, and that really would be x times 5, but most of you are familiar with 5x, equals 4. So this is the base, this is the answer, this is the power. So if I were to rewrite this, it would become 3 to the... So I now want to put it in exponential form. 3 to the 4th equals 5x. So what's 3 to the 4th? You can type that in your calculator.
81.
So 81 equals 5x.
Oh, no.
Divide it by 5. And x equals 16.2 is what somebody said. And you're done. That's it for that kind of a problem. Okay. Here's another way that some people prefer to solve logarithms. If you go into chemistry or physics or something else, here's how they're going to teach you to solve this problem. Instead of rewriting it, they're just going to say, put a 3 underneath. So put the same base. So whatever is here, do that to both sides, and that gets rid of it that way.
That actually makes sense. Whoa, let's do it that way.
Okay. So this is the idea, like writing in exponential form is the idea of how this works. But they don't give you that idea. They're just like, do this, and they go away. So like if you had this log 7 of 2x equals 10, you could just say, let's put a 7 here and a 7 here. These go away. 2x equals 7 to the 10th, which is a really big number. Okay. So that's the idea behind it. the theory behind it is 7 is the base, 10 is the power, and 2x is the answer. Okay. So that's if it starts the logarithm, okay? What if it starts as an exponent? So let's say it starts as 5 to the 3x equals 524. 5 times itself, how many times is 524? I don't know. It doesn't work out very nice. So here's what we do. We rewrite it as a logarithm. So log base, what's the base? What's the answer? And what's the power? So now on your calculator you can type this in. And it's going to tell you what that is. Log 5, 524. $3.890. So 3.89? Is that right? And now to get it, the x alone, we just divide each side by 3. One point.
Why is it 1.29?
Yes. Most of them will be decimals.
You just write x equals 3.8.
Yeah, you could write 3.89 over 3. Are you ready for a crazy one, or should we keep it basic? Here, let's do this before I do the next one that is going to be kind of weird. So I have one more crazy one, and we're going to have to do a lot of problems for practice. But anyways, here's the next problem. This is the stuff that has the variable, right? What do we do when we have the stuff with the variable and we have plus something with it? What do we normally do? Say I had 3x plus 5 equals 7. What do you normally do? Yeah, you'd minus the 5 over, right? Well, it's the same idea. You want to get that stuff with the variable alone, so I'm going to minus the 820. So I have 10, 5 plus 2x equals whatever 49,600 minus 820 is.
Yep, 48780.
Okay, so now that I have it to here, we are going to write it as a logarithm. Here's how people teach you to do this problem. They'll say take log of the base here and do it to both sides, and then it's gone. So let's say 5 plus 2x equals log 10 of 48,780. Because the base was 10, right? So log base 10, the answer was 4878, and the power was 5 plus 2x. So we just rewrote it in logarithm form. But that's how people teach you to do it. They don't tell you the understanding as to how it works. They just say do log base 10 on each side. Okay. So log is base 10. So realistically, we don't have to write the log base 10, right? So you just hit that on your calculator, log 48,780. What does it give you? 4.680. So now what do we do to solve the rest of the way for x? Yeah, so we're going to minus the 5 and then divide it by 2. Negative point what?
Oh wait, no, that's after I thought that.
Oh, that's after.
Yeah,
Okay.
that's the answer.
So x equals negative 0.155. Okay, here's the last thing. Are you ready for the last thing that I'll teach you? Not pretty much. I mean, this will pretty much cover. This is 3/4 of your test that you've learned today.
See, the problem is that we've done so much hard stuff and do all this simple stuff. Like, I don't know if this is right. Because, you're right. You go ahead.
Okay, so before we get any further on this problem, I want to go back to this problem.
What? Oh,
What do you do on this stuff on the right? X squared minus 3x minus 40 equals 0. What do you do? Factor, good. Some of you remember that. What times what is x squared?
X.
What times what is 40 and adds to be negative 3? 1 and 40 multiplied to be 42 and 23 doesn't. 4 and 10, 5 and 8. What's 8 minus 5? So that's the one that works. Minus 8 plus 5. That multiplies to be negative 40 and adds to be negative 3. And then we would take each of those and put each of those equal to 0, right? I'd get x equals 8 and I'd get x equals negative 5. So this is stuff that we've done. We're going to carry this over to some new stuff. Just follow this idea. 3 to the x times 3 to the 2x. What does that make? What do you do with the powers? Because you add the powers, right?
Yeah.
So in this one over here to the left, when it says e to the 2x, we've added an x plus an x. Because what's 1x plus 1x?
2x.
Okay. So we're going to factor it. We say it's quadratic in nature because this is squared and this is half of it. So e to the x times e to the x. 1x plus 1x makes 2x. So that's e squared x. We've already discovered over here that negative 8 and positive 5 multiplied to be negative 30 and add to be negative 3.
Interesting. Okay.
So it's the same idea of factoring, but now we're going to take each factor and put it equal to 0. So we now have two different things. They're each equal to 0. So let's solve this first one. How do I get rid of the minus 8? Add 8. So e to the x equals 8. What do you do when the variable is an exponent to solve? Rewrite it as a logarithm, okay? So anytime your variable is an exponent, rewrite it as a logarithm. So this is the base, this is the power, this is the answer. Logarithms go log base. So what's log e? ln. And then the answer is 8 equals x. There's your answer. X equals the natural log of 8. And you can type that in your calculator. Go to your calculator, ln of 8. 2.079.
Is that how you want us to do it? Like, you'll figure out what x is first and then go?
Yeah. Okay, now here's the next one. I minus the 5. What is this negative 5 telling you? That I have some number to a power equals a negative. Is that possible? Let's choose a number. I choose 4. Can you guys do anything as a power that's going to make this come out to be negative?
I don't know.
What if I put a negative 1 right here? What does that negative do to it? That makes it 1/4, right? Can I do anything with a power to make a positive number turn negative? No. So e to the x equals negative 5 is not possible. Okay? So the only one that works is this one. If I would have tried this to rewrite it this way, I'd have ln of negative 5 equals x, right? So I go to my calculator, I hit ln of negative 5, and what's it going to tell me? All calculations must result in a real number. This is a non-real answer, so in other words, it doesn't work.
Yeah, can you turn it to non-real mode?
You can, and it pulls up eyes and different
That would be
craziness.
helpful. Why don't
Yeah, that would be.
Yeah, why couldn't we use our calculators to know eyes?
Because I wanted you to use the one that's built in.
Well, why didn't we use this one? In college,
You can't turn it on without. Wait,
Okay, so that is a lot of problems. Next time in class, we'll work on them. Yeah, that's all of them. So make sure you work on them so you have questions, okay?